So we're going to review some of the main topics from Module 6 that you're going to be expected to know on the test. So in question 1, we're going to use the trig function y equals negative 1.5 cosine of 3x plus 3 pi over 2 to complete parts A, B, C, and D. So in part A, we want to determine the amplitude. And the amplitude of a trig function is always the absolute value of A. And in our given function, A is negative 1.5, so the absolute value of negative 1.5, which is a positive 1.5. Determine the period. So the period is 2 pi over b. b is the value in front of x, and in this equation, b is 3, and 2 pi over 3 cannot be simplified, so that is our period. The phase shift is negative c over b, which, given our equation, is going to be negative 3 pi over 2 over 3, which we want to simplify. We can rewrite that as negative 3 pi over 2 times 1/3. The 3's will cancel, and we're left with negative pi over 2 as the phase shift. So what this tells me is that my cosine function, since there's no vertical shift, the max is at 1.5, the min is negative 1.5. I can fit one cycle of my cosine function in 2 pi over 3, and my graph has been shifted to the left by pi over 2. So let's go ahead and graph one cycle of our function. So when we go to pick the starting point of our cosine graph, we're going to use the fact that we've taken our cosine graph and we shifted left pi over 2. So normally the cosine function would start at 0, 1. Because we have a phase shift of negative pi over 2, it would typically start at negative pi over 2, 1, which would be right here. But our amplitude is 1.5, and it has a negative in front, which tells me that it's actually been reflected. So the 1.5 would change us that the new max is at 1.5, but because we have the negative, it actually tells us we're going to have negative pi over 2, negative 1.5. So my first point is going to be at negative pi over 2, negative 1.5. And now when I pick my next point, I'm going to have negative pi over 3, 0. And then at pi over 6, I'd be at positive 1.5. Then I'd have 0, 0. A positive pi over 6 would give us a negative 1.5. And we have now graphed one cycle of our cosine function. And if I connect my points, which I did not do a very good job, that's one cycle that's been of our cosine function that's been shifted left pi over 2. It has a period. If we were to go from negative pi over 2 to a positive pi over 6, would give us a period of 2 pi over 3. And we can continue graphing to get more of what the cycle looks like, but we only needed one cycle of cosine. All right, so in question 2, we want to find the equation of our graph, and we want to be able to justify our answer. So what that means is we want to be able to explain how we know that is the equation. So the first thing we always like to start with is determining between sine and cosine. And because we have started on the y-axis, I'm going to say this is a cosine graph. Okay. If I look, my max is at 3 and my min is at negative 3. That tells me that I have an amplitude of 3. I don't have a vertical shift and I don't have a phase shift. Now I just have to figure out the period. I know that the very last line here is 16 pi, so if I look, that tells me my units are pi. So each tick mark here represents pi, and if we figure out where one cosine cycle would end, we would start at the 0, 3, we'd end where we come back to a max at 3, and that would happen at 8 pi. So that tells me my period is 8 pi. Given our amplitude and period, we now have enough information to write the equation for this cosine graph. So my amplitude is 3. Typically that would tell me A is 3. And I just have to check to see if there's a reflection, which there isn't because we started at a positive number. So my amplitude A is just 3. Now we have to figure out what B is. So this comes from knowing our period. We typically find the period by doing 2 pi over B. But we know in this case 2 pi over B has to equal 8 pi. We put 8 pi over 1, we cross multiply. We get that 8 pi times B has to equal 2 pi. Divide by 8 pi to get B by itself. And when I simplify 2 pi over 8 pi, we get that B has to equal 1/4. So now we have all of the necessary information to write the equation of our graph, and it is going to be y equals 3 cosine of 1/4 x. And we can use Desmos to double check that by making sure we put our step as pi so that we can see the entire graph. Okay. So in question 3, we want to know which equation is the function displayed in the graph below. So straight off the bat, looking at the shape of my graph, I know I can eliminate secant. Because secant is the reciprocal of cosine, so I know it's going to have U-shaped graphs in it. So the shape alone of this graph tells me that it's either tangent or cotangent. And then because none of our remaining 3 options have a negative in front, I know that I can eliminate tangent as well, because tangent normally starts in negative values and then curves up to positive. So that just leaves me with y equals cotangent of x or y equals cotangent of 2x. So if we look at the normal graph of cotangent, the period is normally pi, and the location of our asymptotes are at x equals k pi. So they're multiples of pi. And if we look at our graph, our period in our graph its period is actually pi over 2, and the location of its asymptotes occur at multiples of pi over 2, so k pi over 2. And if we're comparing our graph to the normal graph of cotangent, I can see that everything is split exactly in 2, so that would only happen if b was 2. So that tells me that it has to be y equals cotangent of 2x. You could also use Desmos, graph each of those equations to figure out which one matches as well. That is another way to figure out which equation is the function in our graph. So last example would be a section 4 example, figuring out the regression equation for a sinusoidal function. So our data represents the number of people at the Columbus Zoo for a given day at the zoo during the year. So day 1 would be January 1st, and then we would continue on for the rest of the 364 days of the year. So we have data for the days and the number of people. We want to calculate the regression equation for the data. So depending on whether or not you use Desmos or you use your calculator, you're actually going to get 2 different equations. And normally these 2 equations would match up pretty closely, but in this case they are a bit different. So make sure you look at the equation for whichever method you used, whether it's Desmos or your graphing calculator, to see which of yours is correct. So if you use Desmos, after you create your table and then write the equation to approximate your function, you should get y equals negative 164.7 0.79 sine of 0.148 x plus 45.711 plus 322.59. And if you use your calculator to get the equation, you should get y equals 169.942 sine of 0.022x minus 2.196 plus 354.93. And as I stated, these should match up a little bit more. Usually Desmos and your calculator are actually pretty similar in what equation you get, but for some reason this data does not match up as nicely when you use Desmos. So again, in B, depending on which equation you use, you can get a different value for how many people you expect to be at the zoo on the 170th day of the year. So what we're going to do here, depending on which equation you have, you're going to plug in 170 for x. So if you use your equation from Desmos, you should get about 242 people. And then if you use the equation given from your calculator, you get about 525 people. And I would actually say in this example, the calculator gives you a better regression equation, because if you have Desmos pulled up and you look at the sign graph that fits with our data, it actually because 170 days falls between 150 and 202, based on this information, the number of people grows from 500 to 550. So I would expect the number of people to fall somewhere between there, which our calculator equation does. But if you were to look at the Desmos, between those values, Desmos goes down and then back up again. So I would say, for the last one, do you feel this is a good model to represent the attendance every year? I would say for Desmos, it is not a good model. The equation we got from Desmos does not fit our data very well. And if you have Desmos pulled up to see this, you can see that our sign graph doesn't really go through a lot of our data points. But the equation given to you from your calculator, if you were to graph that one, the calculator is a good model. It fits more of our data points and therefore gives us a more accurate representation of the regression equation.